So we've worked out that these 500 million year old rocks represent a river. These ones were deposited along a coastline, and these ones were formed beneath an ancient ocean. Fantastic. Except there's a problem. They're all in the wrong place. Over hundreds of millions of years, plate tectonics has ripped continents apart, smashed them together, rotated them, and carried them thousands of kilometers across the planet. So if we want to reconstruct Earth 500 million years ago, identifying ancient environments is only half the job. We also have to figure out where those environments actually were. And luckily enough, the rocks can help us here too. When certain minerals form, they can preserve a record of Earth's magnetic field. Because Earth's magnetic field changes orientation relative to the surface depending on latitude, geoscientists can measure this ancient magnetism called paleomagnetism. I know, very original. Now, this can help us estimate where a piece of crust was positioned when those rocks formed. But alongside that, there are also geological clues. Mountain belts that are separated by oceans today can contain rocks of similar ages, structures, and geological histories. It's a bit like finding two ripped pieces of paper and realizing their edges fit together. But to add to that, we can also reconstruct ancient plate boundaries, faults, volcanic arcs, and collisions. Fossils also are very helpful. Finding closely related organisms in rocks of the same age on continents now separated by oceans can help us establish connections between ancient environments. Mesosaurus is a classic example. But then there's also geochemistry. Chemical and isotopic signatures preserved within rocks can tell us about ancient temperatures, ocean chemistry, weathering, and even changes in the global carbon cycle. So now imagine doing this not at one location, but at thousands of locations across the world. We date the rocks, we determine how they formed, we reconstruct where the tectonic plates were, we correlate the rocks of similar ages, and then we start joining the dots like children with coloring pencils. Suddenly we can estimate where continents existed, where shallow seas flooded them, where coastlines have been, and where major mountain belts and ocean basins existed. But there's something really important for us all to understand. These maps aren't photographs. The further back in time we go, the more evidence has been destroyed by erosion, buried and metamorphosed and recycled back into the mantle. So paleogeographic maps are scientific models, and some areas are much better constrained than others. But the key thing here is they're models built from evidence, meaning that when you look back at a reconstruction of Earth from 500 million years ago, you're actually looking at thousands of geological clues stitched together to resurrect a world that disappeared almost 500 million years ago. If you enjoyed this series, I'm Mr. Earth Guy, geologist, geoscientist. Come and join me on this journey of discovery. I'll see you in the next one.